So, good morning, everybody. So my name is Diederik Schoeneck. In daily life, I work for Procter & Gamble here in Stroombeek, just north of Brussels. But today, I'm more representing ECETOC, and I would like to present to you the outcome of the ECETOC environmental modeling workshop we had in 2017. And when Dick was talking, I was really asking myself to what extent is there correspondence between what he is saying and what this modeling workshop was saying. Now you should expect kind of a helicopter view. So the workshop was not specifically about the EUSES. Of course, we touched upon the EUSES, but that was not the main thing. We were looking at what kind of models, low tier, high tier, were used in different sectors in industry and capture a little bit the state of the science in that domain between, let's say, our peers. However, later we convened the ECETOC TRA, and ECETOC is the European Center for Ecotoxicology and Toxicology of Chemicals, and they have a task force on tiered risk assessment. And we convened this task force and asked ourselves, now in fact, these recommendations from this workshop, if we would apply them to EUSES, what would that mean? And so what I'm going to present today is also how these more generic recommendations might impact our recommendations for EUSES update. So, yeah, speaking about the workshop, actually the official title was Advanced in Environmental Exposure Modeling, Bridging the Gap Between Research and Application. It was held early May last year in Brussels, and actually the chairman is here in the room, was Todd, and there were several people represented the workshop, so if I say something wrong or incomplete, please correct me, you can always chime in. So we brought people together from academia, regulators, regulatory agencies and industry, as well as some contractors and consultants. And as I said, we compared the current practice in different industry sectors, basically, so what we call general chemicals and biocides group, then the agrochemical pesticide cluster, the pharmaceuticals cluster, and then we also looked at the practice of modeling for assessing P and B properties of chemicals as a separate item. There was also a model fair with demonstrations, so we had some hands-on demonstrations of the latest models. There is an ECETOC report number 35 that is publicly available if you're interested. It contains the abstracts, and also it produced two types of other outcomes, actually a set of recommendations for model practitioners and a couple of consensus principles of good modeling practice and decision making, which you probably will recognize if we think what Dick just told us. So the timing was not just accidental. Actually, we saw that the REACH registrations, 3 waves, were coming to an end, but we felt this was a good moment for a bit of a timeout and thinking what we wanted next. We were also inspired to some extent by the United States because they had done some exercises. They issued reports to the US National Research Council on exposure science in the 21st century, vision and strategy, and then a similar document, not for the exposure side, but for the toxicology side, mainly in the human area. But anyway, they took kind of a long-term vision on what they really wanted. So in that vein, we brought together these people. Now, very briefly, the main topics that we taught in this workshop were aspects related to uncertainties, and to some extent it comes back to the point that Chris was mentioning of the overlap between a pack distribution and a PNEC distribution, and what's the probability of making a wrong judgment. We looked at harmonized approaches for assessing exposure between industry sector groups. Are we not going too far out on our own domain and not talking enough to each other? A common theme was also applicability domain challenges, including what do you do with ionizable chemicals, for example, which were not so much in scope when the original models were developed, aspects of spatial and temporal refinements, and so on. So they are things that are common between many industry sectors. Another topic is also the integration of environmental fate models with what I would call more ecosystem models that really, and that's what you want in the end, is predict and model the health of your ecosystem and the environment, not just get a number below 1 or above 1, but you want to see some you can feel and see. So that was a topic, and then obviously the topic of chemical mixtures, UVCB assessments. What do you do if your chemical transforms very quickly, or how do you do the assessment and so on. So they were common topics that we had between the sectors. Okay, now I'll present a few tables which are basically the outcome of the workshop. The first table is about the recommendation. As I said, it is high level. Don't expect too many specifics. The way you should read this slide is basically in the left-hand column there are basically 3 recommendations for model practitioners. Then in the middle column there is kind of an approach how you could do this, and then in the third column we looked at what this could mean for EUSES specifically. So I think the model community should really promote the fit-for-purpose modeling. It's be very, very specific of what kind of scientific answer your model can answer, what kind of question the model can answer, and that will help you a lot in your work. In doing that, we were more in favor. We were not so much in favor, I think, of make simple naked models, but have more like a decision tree that you can go from, let's say, a simpler to a more sophisticated assessment, but have a very clear path how you do this. Now, if you look at EUSES, in my view, for my practice, it can do a lot. It's an amazingly versatile tool, but it's a big box, and you don't have a lot of differentiation within the model, and also it doesn't give a good idea if you calculate something what the uncertainties are. So we see in industry EUSES mainly still as a lower tier model, and we wonder how some of the models that are also developed, for example, in the pesticide sector or more specific river models, how they could be combined with the EUSES outcome. At what point do we jump from one model to another? Another recommendation is to ensure the best current practice of science of exposure assessment. So communicate between the different industry sectors. That's more a recommendation for industry internally when we have our specific LRI program, research program, that we really bring the science from one project to another. And also there, we discussed the aspect for EUSES, specifically the aspect of uncertainty. Another recommendation is maybe that if you want to change something to the model, it's good to develop some case studies to illustrate how it could work, and I think that would be then much more convincing for this group, for example, to adopt or reject a certain revision of the model. So make a case study in advance and give the illustration. Then towards the future, also a generic recommendation, it's encourage involvement communication with all stakeholders. I think we're doing this perfectly today in this workshop where we really bring various stakeholders together on a problem. The only extra advice we would give is don't do this like in the past, more or less ad hoc, but put some structure in the process that you at regular intervals can have a check of where you are. Okay, then there were a few consensus principles on good modeling practice and application to decision making. I think that to some extent say the same things as Dick has been proposing, although, as I said, we are to some extent in favor of a decision process. So when you have a problem definition and a question, make a decision tree so that you know how accurate your assessment is supposed to be. Then the other thing is, parsimony, the word has been mentioned already highly. So loss of parsimony in exposure modeling is a threat. So we also agree that you keep it as simple as possible, but still fits for purpose. And then another recommendation is to be very specific about guidance for your applicability domain. We see this more and more as we run more and more water purifiers, run more and more chemicals in regulatory risk assessments, and I think EUSES can do much better on that side, or the PGBs for EUSES, that applicability domains are much more clearly spelled out when it can be used. And also the question, what do you do if the applicability domain is just not correct? Because in industry we have very often tried to force fit a chemical through EUSES, which is a bit strange approach. So to continue with the consensus principles for good modeling, this is specifically About uncertainty, as I said, we are to some extent fan of tiered assessments, and when you do the tiers, you reduce your uncertainty level as you go from high to low. And I think we're also very much inspired these days by what happens in EFSA in the pesticide. Something went wrong. In the pesticide industry, where they have just issued a guidance document on uncertainty assessment. So, as I understand it, for pesticide risk assessment, you have really to give uncertainty assessments together with your risk. Okay, so just to continue, another recommendation which is very logical to all of you, so improving the quality of the input data for reducing uncertainty, so garbage in, garbage out, the principle, and doing sensitivity analysis sufficiently so that you understand what you're really working on. But it's very important because your data and the data from the testing are so critically important for having a good model outcome. Yeah, since we're talking still about uncertainty, modeling results must be communicated along with the associated level of uncertainty and confidence. So yeah, I think we mentioned that point already. Okay, then there were some other principles that may not be directly relevant, but still keep industry very busy, or so what to do with modeling chemical mixtures and UVCBs? How do you take a representative middle value, or do you take the extremes? How do you run those in risk assessment? And then also a bit more longer term out to the ecosystem thinking, how do you combine chemical stressors with non-chemical stressors and combine those models? But as I said, for the work that we have to do, that is not immediately important. What is, however, maybe more important, but nobody talks about this, is the kind of principle of reverse modeling. As industry, we do some monitoring of our chemicals in the environment, and sometimes we find concentrations that we cannot explain by the model, and then what we try to do is take the environmental concentrations if they are sufficiently robust as a true value, and try to see and model back what could have been the emissions and the properties of the chemicals. And that is something that we see very little in practice, but it's a way of working that we can do already. So maybe longer term we also need to think to what extent that might be possible. And it's the intention of Cefic LRI over the next years in their research programs to dive a bit more into those aspects. So my last slide, some very practical recommendations from the heart, I would say. So I think we very much also in industry like EUSES as a kind of tool to play with. So it's a research model. It can do almost everything, and with the software we built that we hope to see, we hope that this full flexibility and all the knobs available in the cockpit will not change. However, we definitely want a much better user experience. The user experience is awful, but the model itself is very valuable behind it. As Dick presented, 2 to 3 decades of science have been between the first Challenger's coding and now, so I think it's really fair to have a look what should be done next and not stay what we have. We fully understand this shall be a tiered process. Do the very clear things first, and then take some time to find out the rest, what needs to be done. And as industry, we have this ECETOC TRA, Tiered Risk Assessment Task Force, and we are very interested to keep this task force alive and be kind of a sounding board and a support for the EUSES update process over the next year. So industry people are ready to follow and comment on this process. Voila. That's it.